Hello, everyone. I would like to record a few sessions to discuss how does large language model work end to end, especially GPT-2 model. So my target audience will be software engineers, but also I will try to make it very easy to follow, so any general audience can also understand it, right? So I want to focus on this GPT-2, which was released 2019, long time ago. Um, Later, we will definitely pull from this repository and then check what's inside. How does this actually work end to end? Yeah, a couple of quick questions. Why do we want to use GPT-2, right? First of all, it's fully open source on its weight, all its parameters, and also it kind of published some of its training data. If we open this one, we will see this. This is its some of the training data is trained on top of this something called web text training set. You can download a portion of it via this link with this web text train.json.l. All right. Another reason we want to use this one is it's a very small model. Okay. Let's look at the Hugging Face page. So it will say it only have less than well zero point 0.1 billion basically, but at this place it's like 137 million. But in a later place it will say it's a 124 million. Which one is true, right? Actually, this one is the correct number. All right. It also mentioned in their paper this is statement. They say in their paper they refer it to 117 million, which is wrong. All right. So this is a very small model, meaning we can effectively run it locally and offline. Even run it without a decent GPU on your CPU, you can probably just run it. And also potentially, I think very likely you can also run it on mobile devices, right? That's why we want to use this model. If you look at this Hugging Face page, it said that it has like this series has four different models. We're only going to use the smallest one, okay, which is only have this amount of parameters. All right. Next reason we want to use it is because it's easy for us to do fine tuning, which we will also cover it later. Because it published the academic paper over here, um, so lots of researchers uh, and engineers read this and try to reproduce this GPT-2. So as a result, GPT-2 is still used by researchers in the academic settings, right? Um, Look at the how many downloads. It's quite a good number. People are still using it for different reasons, right? For example, we can use it to understand the transform architecture. We can understand language modeling in general, even some prompt engineering and some ethical considerations in the large language model. For example, in this README file, it kind of explains some of the bias that will ever happen and limitation in the model, right? For example, when it talk about white men work these kind of roles, but a black man work in these kind of roles, right? It's kind of obviously not correct, especially you see slave, right? It's 100% not correct. That's why it's a good model for us to learn some of its limitation bias from this ethical point of view. All right. Finally, because any large language model, even for this tiny one, it still has over 100 million parameters. It's very hard to understand how these parameters has been collaboratively working together to give us a good result. So as a result, a smaller model, meaning it's easier to do some systematical, mathematical interpretability research, right? You can interpret how does this parameter change will eventually impact the final output. So all these reasons, we end up planning to use this GPT-2 small model to do this end-to-end testing. All right. Um, let's quickly back to the topic. Like, what's the large language model, especially GPT model? You probably heard that like large language model are just like deep neural networks that predict the next word in the sequence, right? That's 100% true. And also, um, to get this deep neural networking, you need to train it with massive amount of data, right? And when you predict the next word, it kind of based on something called context. In this case, it's based on the context of 4 words: cat, sat, on, a. The output is another word, mat, with a very high probability, high confidence it will be a mat. Okay, um, so essentially, they just predict the next word in the sequence based on the context, and then it will continue, feed the output back into the input, and have this loop until this model generates something called end of sequence or end of text token or symbol. And then it kind of stop over there, right? To a certain extent, many people just call a large language model a glorified autocomplete, right? Because it essentially looks like when you type any message in your mobile phone, it will simply predict and suggest the next word. But obviously, large language model can do it much better. It's very capable of doing many natural language processing works. Okay. Um, Again, when we talk about large language model, you might also have heard that large language model is based on something called transformer, right? That's the architecture for this deep neural network. Um, so this idea was transformer idea was introduced by Google Brain in their famous "Attention is all you need" paper. They kind of propose this transformer architecture. Uh, they say it will, based on this architecture, it will do this natural language processing very well. And you might also heard like it has this transformer have 2 sections. One is this something called encoder, the other is decoder. So in our case, we will only cover the decoder part, which is the section like GPT model have used. Okay. By saying this, let's quickly come back to this one. So to have this large language model, you need to have something called weights or parameters. That's essentially the number in this deep neural network. All these weights, they kind of work together and process the input and predict the next word in the sequence. So it does lots of mathematical computation to generate the output. Okay, that's the first piece. Consider all the weights, all the parameters as a big zip file or a big bundle binary or different kind of zip file, right? We can essentially look into what does this file look like or what's the format of this file. Let's quickly open the Hugging Face for the GPT-2 model. Let's look at the files and versions. So what you will see is um, the parameter file is just less than 1 GB. This is the option. This is 64 FT TF-lite file. This is another one is flex model file, and this one is a safe tensor, and this is a binary file, and this is a RAS model file. Well, all of them are just saved in different format, but essentially consider all of them as a bundled weight file, like a zip file, and you need to have something to load all the weights and then run the whole process. Okay, this process is called inference. To load this file, you need to have some of the programming applications to load and do those calculations for you. There are some popular choices. For example, the top one would just be something called Llama CPP. They use CPP, C++, and C to quickly do the LLM inference, which can do it very fast. Llama CPP has done lots of optimization at hardware level, software level, and model level. which you can easily use in CLI after you install it. You can load the model, you can start doing your inference. You can even have a server run as an API. If there are lots of model you can pick from. See the model category and quite a lot. And also, if you prefer the graphic interface, you can use some of the UIs. Those UI essentially built on top of Llama CPP. Popular choices are like LM Studio and Ollama. Okay, yeah, let's quickly come back and look at this one, right? So for this inference process, it just take a sequence of inputs and then generate the output. But all the weights are essentially just numbers. As a result, these text has to be encoded into like a float point number or a digit before it can do all this calculation. As a result, this process, like convert a text into a number, is something called tokenization. For example, OpenAI have this tokenization platform. You can easily play around with it, right? For example, let's type in something. It will just give you, tell you how many tokens it has, and then what's the integer it is, right? Essentially, it's just these number are feed it into your neural network and generate another integer, another number, and then it will do the decoding and map it back to a text. That's the tokenization process. I'm going to stop it over here, and next session we will deep dive into this tokenization process. Thanks for your watching.